The weapon employment zone capability of the AB Quantum app is really next level, okay? But you have to know how to use it or you're gonna get the wrong answers, okay? So this video is about how to properly use the WEZ feature in AB Quantum. All right, I'm in the WEZ tab right now in the WEZ controller. There's a couple categories of data that you set for it, okay? Up top, you're setting the target, okay? What kind of target are you shooting at and how far away is it? Okay, so if we say 1200, it's going to do a WEZ assessment all the way out to 1200 yards. Okay, we get to set our target type among these different shapes. If you select a circle or a rectangle, it'll let you tell how big it is, okay? Like the radius or the width and the height of the rectangle. Okay, so once you selected your target, then you can look at different types of graphs. Okay, the one we've been looking at is this shot simulation. It's showing you at that range what the model is showing you as far as dispersion that is caused by the variables that you have in there. Okay, that's the shot simulation. Your probability of hit graph is showing you how your probability of hit falls off with range. Okay, so like here we have 100% hit probability out through like 600 yards, and then by 1,000 we're at around 50%, okay? And it goes down a little more to 1,200, so that's what that graph is showing you. Now, these other two are showing you what the major components of your dispersion are in both vertical and horizontal, okay? When you look at this vertical uncertainty graph, it's showing you that MV, your muzzle velocity, is your #1 contributor to your vertical uncertainty. So the growth of your vertical dispersion is mainly being driven by muzzle velocity here, okay? DF, that stands for your drag uncertainty or your BCSD of the bullet. That's the second thing. Then you have the rifle, okay, that's the third thing. That would be like the dispersion of the gun, like what groups it shoots. So that's what these vertical and horizontal uncertainty graphs do, okay? The horizontal one is not very useful. It's almost always the wind. If you have a realistic wind uncertainty in there, that is what's driving your horizontal uncertainty. There aren't many other things that drive that other than wind. Okay, so that's what we have as far as these different graph types and target types, okay? Now below that, and the confidence parameters, this is where things can get really squirrely, okay? There's easy buttons in here. You can go with an easy button by selecting a high, medium, or low confidence environment, and that will default all of your uncertainty inputs to those that characterize that analysis, okay? So if you want to compare your rifle to your buddies and apples to apples, who's got the highest hit percentage, you have to have all of these confidence parameters the same. Otherwise, you're not making an apples to apples comparison. All right, so this is one way of doing it, is setting it to high, medium, or low, and it shows you what all the values are corresponding to those. Now, if you want to go custom, you can come in and input every one of these parameters what you want. And basically what these are, they're the uncertainty brackets around a lot of your inputs. So you say the target's at 1,000, but what if there's a chance it could be 1,005 yards or 990 yards? Then you would say you have some range uncertainty. Well, how you characterize that range uncertainty to the WEZ program means everything to how it's, calculating your WEZ. So these inputs, the thing that you have to understand about these uncertainty inputs, they're standard deviations, okay? Which makes sense for muzzle velocity because we typically get muzzle velocity as a standard deviation, like chronographs report that, so it's natural. Drag uncertainty, that's the BCSD of your bullets. 1% is a good number for good bullets. But like your wind speed, it may not be intuitive that if you have a 4-mile-an-hour bracket that's like plus or minus 2 miles an hour, that you want to input a 1 for that uncertainty parameter, because your bracket is going to be plus or minus 2 standard deviations. That captures 95% of the shots. And so you put in a 1 for wind speed if you wanted to model a plus or minus 2 mile per hour bracket, okay? That's what's important to understand about these inputs, is that they're standard deviations, okay? And once you've inputted all those correctly, you'll see your WEZ above respond to that. You'll get a different hit percentage based on these uncertainties. Likewise, if you change the target size, you'll get a different hit percentage. You can really spend a lot of time in here with these WEZ metrics, seeing what effect the different ones have. You might learn some things. It might surprise you to see how much effect some things have and how little effect other things have. And it can depend on the size of your target or the range to your target. There really isn't a one-size-fits-all takeaway from WEZ. It depends a lot on the performance that you're modeling and the type of analysis that you're doing with it. So that's where you go to characterize the WEZ. That's how you get to see the different types of plots that are available through WEZ, and where you go to adjust your uncertainty parameters that define what the weapon employment zone is based on.